So this session is going to be quite a multifaceted one. We'll have an initial round table with these three guests. Then there'll be a fireside chat. And then there'll be another round table. And the key objective is really to dive down into some of the innovations that they're working on, and at the same time, put out there what needs to be done to scale things up, and where you maybe could play a role in taking things to the next level. And so what I'd like to first of all do is just to go around the table here with my guests and ask them first, just very briefly, tell us what it is about what they're doing that's very different, why it's needed now, and then we'll get into how we can move forward from there. So I'll turn to my right first. Geoffrey, could you please give us a few words on that? I think you need this microphone. Hope it's working.
Thank you, Max. Hi, everyone. I'm very happy to be here with you. So I'm the general manager and co-founder of Sustainair. Sustainair is a French company, and we developed and patented HVAC system. HVAC stands for heating, ventilation, and air conditioning. So in a nutshell, we sell an air conditioning system which is low carbon, low energy, and which uses renewable energy to be powered. So the big difference with current equipment for air conditioning is really simple. Air conditioning equipments use refrigerant gases. So in any type of equipment, being heat pump, chiller, whatever, even in your car, you have a load of refrigerant in the system. And those refrigerants leak to the atmosphere. It's 10% of the load every year. They leak to the atmosphere, and they have a warming power. It's called GWP, global warming power. And the global warming power of those refrigerants is 500,000, 2,000, 3,000 times the one of the carbon. Yes? So when 1 kilogram of refrigerant leak from the system, it means 1 ton or 2 tons or 3 tons of CO2 in the atmosphere. So refrigerants is a huge threat for the climate, of course. The International Energy Agency thinks that in 2050 they will represent 20% of greenhouse gases, right? So it's huge. Our system doesn't use refrigerant. We are based our system on a very simple idea, on a very 1,000-year-old principle, as I like to say, which is when hot air is humidified, its temperature drops, right? So my grandmother used to do that. So the temperature drops by 4 or 5 degrees, like in the patios in the Mediterranean houses. There is a fountain. It's not only to be nice, it's nice, but it's also, it decreases the temperature by 4, 5, 6 degrees. We use this idea and we put on it algorithms, data, technology, and we can lower the temperature by 20 degrees. So the external air temperature is 35. We can put air inside the building of 20 degrees. So it's a natural air conditioning system. It uses the air, a very bit of water, and heat, sun heat, solar thermal energy. And basically that's it. It's not a dream anymore. We sold 3 of those systems. It's already in operation in France for the moment since 2017. EDF, Dalkia bought a system from us. They committed to reduce energy consumption in a swimming pool in the east of France by 30%. And they're doing that with our system. So the city is saving 36,000 euros a year on the energy bill, and the carbon emission are lowered in the same proportion. So that's what we do.
Thank you very much, Geoffroy.
Right.
That sounds fascinating. So natural air conditioning is what you're basically putting into place. Key now is how do we scale that up?
Yeah.
Let me first turn to the far left. Not necessarily you're a far leftist, Helen. Can you tell us a bit about what you do and what your innovation is and how it's really trying to make a difference?
Yes, I will try to explain. I think, can I ask one question first? Is it is this the same as sorptive cooling? Do you also call that sorptive cooling? Yeah. Okay, to be sure, because we think a lot about refrigerants where I work as well, using heat pumps and believing in future natural refrigerants. We started to actually use CO2 in our systems. Okay, getting back to what we're doing. I work for E.ON, a company within E.ON that we name Ectogrid. It's a technology, it's actually hydraulics, it's how you send water back and forward. And boost energy and use it, share energy within a city. So what we do is that we bring excess energy from one place and put it where it's needed. At the same time, we bring the cold part. If you have a heat pump, you produce warm in one side, cool in the other. And we bring the cold back to the one that needs to chill something. So for instance, imagine a large data center have a lot of waste heat. It might be, actually I know the installed data center capacity in Amsterdam is 1.5 gigawatt.
Wow.
It's quite a lot.
Yeah.
That heat is wasted, most of it. But it's only 35 degrees, isn't warm enough. But this system enables you to that you can utilize really low temperature waste heat. For instance, the metro can heat the buildings. So this is a system that we have developed and now deployed in about 5 places. And we see it's actually working. It's a clever hydraulics behind it. And we do connect it together with the power system. So it's operated on waste heat and electric power. But when the electric power is available to keep the cost and carbon footprint down. So short on that one.
Thank you, Helen. Short but very informative. So thank you very much for those introductory insights. Now, last but not least, for he was the last to arrive, but we won't hold that against him, is Yaron Shenhav. Yaron, what is it that SolCold does, and how are you trying to push the agenda forward much faster?
Yeah, I mean, I would like first to say it's quite strange that in the middle of the winter right now we are talking about cooling, all of us, cooling technologies, and myself as well. I come from Israel, come from a very hot country. I would say about 9 months out of 12, it is summer in Israel. In Israel, you have a lot of consumption for cooling. And I don't know if you guys can relate to this, but for example, in Israel, in the summer, and I can say that for every hot country out there, for example, only just getting inside your car in summertime, when your car was parked under the sun, it's like a trauma event. I mean, you open the door, it's a sauna inside, it's 60 to 70 degrees inside. This is it is a good example for people who can relate to this, who comes from hot countries, to what we do. We're developing a technology which is completely new. We're developing a coating material, which is a multi-layer coating material, practically based on a physics phenomenon named anti-Stokes fluorescence, which I am quite sure the majority of you never heard of it. Basically what it means is that we are creating nanoparticles inside our material that when they are being hit, I would say, with a solar radiation or with windows from the solar radiation, they are reacting to this in excitation and releasing of energy, which has a higher energy than the energy that they were absorbed. Meaning basically, the moment that our coating material is exposed to sunlight, it starts emitting higher energy back into the atmosphere and basically losing its own energy. And when it is losing its own energy, it starts dropping its own temperature. It has an active cooling power. Now, if I go back to this car example which I started with, if we coat a car with our material, which you basically would, I wouldn't say not need an air condition for very, very hot days, but you will limit the use of it massively. Now you can imagine that applicable not only obviously for cars, but for the rooftop of buildings, for agriculture, for airplanes, for shipping, for containers, for basically anything that is exposed to sunlight. This is one thing, because we need sunlight, and the other thing is that it needs to be cooled down. Basically anything that except these two terms. What else can I say? So we are a startup right now. We're not yet in the production or in sales like these two nice guys besides me. But we are heading there. In our roadmap, we're starting the initial sales in the end of this year. We have tests already lined up, companies that wants to test it with us. European companies, Australian companies, Chinese companies, different sectors. I mean, we have Samsung on one hand. We have Taijing, which makes clothes for T-shirts. I mean, you want to run with a T-shirt to cool you down. On the other aspect, we have Airbus. Completely different companies. And to your question, what it will help, obviously, if you reduce the consumption of air condition in any way you can, you obviously reduce the energy consumption that in the car and in the entire city even. And when you reduce that, you basically reduce gas emission, you reduce everything.
Thank you, Yaron. We clearly have a great choir here. You're all singing, alto, tenor, soprano, or whatever, but you're all singing the same song. But it's also clear to me, although you're all doing things which are new and are needed, the scale isn't quite there yet for the challenge that we need to really address as humanity on this planet. And one is an open question to all of you now. What is needed in this sector, what you're doing, to really ramp things up, to scale things up, to get things at a level where it's more than just, you're about to go to market or you're 5 cities and so forth. What's needed to really advance this agenda? I'll start with you first, Helen.
I think I've been working with this now for 2.5 years, I think it is. And during that time, it changed tremendously because legislation and regulation is moving into the right direction. And I think there are so many countries now not allowing fossil gas for new build. So I would claim, looking into our pipeline, I think, it's starting to happen. But I think you need organized city planning. You need a smart city infrastructure because someone needs to manage and how you make choices for your new properties. They need to set high standards on this. So I think if you put the right regulation in place, this will happen because it's actually, from a cost perspective, efficient as well.
In that context, I hope you join us tomorrow morning. I'm also moderating another panel here. That's on smart cities. But what's your view, Yaron, in terms of what's needed? She mentioned legislation, regulation, smart cities, and so forth. What do you think?
Actually, don't quite share this view, I would say. I see a lot of green solutions, even from the previous years going into this day. And I can say that the majority of them, when they are based on regulation or on subsidies, etc., it can allow them, I would say, for the runway, for the few years to go and lift. But if it is not an economical, viable product, if it is not for the end customer, if it is not right for him, beneficial for him to buy it, it will not be a solution that will be adopted. And you're talking about adoption, massive adoption.
Monsieur Lucifer est attendu dans les combles de la salle H. Monsieur Lucifer.
I'm not Lucifer.
Nothing to do with me.
So I mean, to me, and this is the main point that I'm practicing in my company. First and foremost, we need to be very, very cost effective. We need to, for the customer that he will want to buy it, not because of regulation, not because of subsidy, because he wants to. It will be beneficial for him. It will save him money.
Okay, Geoffrey?
Well, I would agree with both
wise answer.
Helen and Yaron. I think we need regulation and central incentive to make change happen faster. But obviously, if it's not economically viable, no one would buy a system that is not economically viable. So that's why I think we all have a work to do to show that the return on investment is here.
We're right in the middle of the last question, I think, in this session, where I'd already asked them to say what their innovations were, what they saw, the kind of the challenges to scaling up. So my last question, I think very brief. If you were to just tell, say, a politician or a senior banker or someone what the opportunity was, why they should be investing in what you're doing now, what would you say, each of you? Geoffroy, you start. Ladies, giving you the floor.
I start?
Yes.
Yeah, thank you, Helen.
So
let's see. I think the history is moving forward. So what I mean by that, for example, in buildings, the more you invest in the ecological value of a building, the more you have in your balance sheet and the higher price you can get from your rent. So there is an economical value behind the ecological value. It has to go together. That's what, as a company, we try to do. But I will give you a very simple example. I am in a discussion with a very big real estate developer in Paris. And they plan, they're hesitating. They plan either to put some chillers to do the air conditioning in an office building in the 12th arrondissement of Paris. And they say, we have planned, the conception is that we put those chillers and the refrigerant is A410, A410, and this gas will be prohibited by European Union in 2025.
Oh.
Right? And apparently those guys don't know it. Maybe they will realize that, but that means if you don't invest in the right direction right now, you will have to spend more money in a very short period of time, because when you refrigerant is prohibited, you not only have to change the refrigerant, you have to change the whole equipment. So, of course, my objective, my will is for the climate change. But even in euros, in dollars, I think the right direction to take is the one that society deeply needs and wants, because that's where the value is already or will be, And if they want to talk about return on investment, I can show them figures on, total cost, etc. I can prove it.
I know you can.
But anyway.
I can see it in your eyes. Thank you very much for that. Helen, you ready now?
Absolutely.
Thank you. Floor is yours.
It's always good to invest in infrastructure, especially infrastructure that enables neighbors to share their access with others. And in this case, you can avoid to put chillers and other equipment on the roof and enable other use for the roofs.
Thank you, Helen. And Yaron, you've got 1 minute,
I have 1 minute.
6 seconds.
Well, from talking to, I would say, many investors in my previous funding round, we don't need money right now, so this is a good way. But from talking to them, I can say that although idealistically they would all want to invest in something that would make a change in the world, eventually it is only about the money in the end of the day. Basically, if you have a good technology and you can show, as you mentioned, the right figures for the return on investment, the money will arrive.
Yaron Shenhav, thank you very much for that. Helen Carlström, also thank you. And Geoffroy Germano, thank you. Thank you all very much for joining us on this first round table of this afternoon.
Second.
First. Oh, continuation, yes.